Okay. Welcome to the Open Specimen web introductory webinar. The goal here is to talk about Open Specimen at a very high level and also give a short live demo just to give you a overall feel of the product. And if you're further interested in learning more, you are welcome to email us and we can have a discussion one-on-one about your requirements and how that can be met with OpenSpecimen. So I'm Srikanth Adiga. I'm CEO and founder of OpenSpecimen. The As I said, the overall agenda of the call would be a bit about background about OpenSpecimen, live demo, and we'll keep the question and answers to the last. But in between, if you're free to post the questions on the chat window, and my colleagues on the call will try to answer that. If not, we'll take all the questions at the end. So with that, I want to start with a case study of a recent implementation, something that happened in, say, the last year or so. Just to give you a overall, just to start with something interesting, a success story kind of thing. Even though this was actually a very big project, so I don't want the takeaway to be that Open Specimen is used for very big projects and not suited for smaller projects. We are just showing this because this is a recent implementation. So the Indiana University was using on-course BSM module, and it's, I think, almost about 15 years old data. I mean, I think they also were using something else before Encore BSM. So overall, the data was huge. And also multiple independent biobanks in IU was using BSM, and we migrated all of them into OpenSpecimen. Uh, there were so it was kind of a multi-site biobank. So they had three repositories: one in IU Indianapolis, one in Tel Aviv in Israel, and one in Italy. All of them collecting specimens for the same kind of clinical trials that were run across multiple sites and local repositories. All of them now centrally log into OpenSpecimen to manage their specimens. So as I said, the numbers are huge. So they had about 7 million plus specimens across 500 or so clinical trials and hundreds of users across the three and the sites that I mentioned. It also involved integration with the robotics freezers, and also they used our APIs to do additional integrations internally. Since it was more one of the bigger groups was more a clinical trials kind of managing the clinical trials, the specimen collections for trials. They create collection kits, send out kits in advance, and all those things. So they use Open Specimen now to manage their whole kit management, right from starting to create the kits in Open Specimen, sending out the kits to the sites, collecting the kits from the sites, etc. And there's a module in Open Specimen that I'll show later called Workflows, which is meant for developing custom workflows based on specific use cases. For example, there is one of the trials has a serum processing workflow, but some other trial would have completely different way of processing serums. So just give me 1 sec. Sorry. So yeah, so we developed a lot of custom workflows, and now they also develop it themselves because we have trained them how to do the workflows. So that's just we also published recently a case study on this. We'll be we can share it with all the registrants shortly. So, going back to OpenSpecimen, since many of you are either new users of OpenSpecimen or looking at adopting OpenSpecimen, I wanted to start with what are the typical challenges, especially when it comes to IT, database, etc. Most biobanks use either are using rudimentary stuff like Excel sheets or homegrown MS Access database or other commercial applications which are kind of meant more for freezer management, where given a specimen you can find out which freezer or rack the specimen is in, or the other cases are where people are using software meant for limbs, which are more generic laboratory information systems and not necessarily meant for biobanks. So all this kind of puts in a lot of challenges or a lot of restrictions on how a biobank can use these kinds of software. The reporting or ability to query for specimens, because in a biobank you keep getting requests for specimens that the researchers are asking for different kinds of specimens. Now your ability to go in and find specimens of interest uh, in the without needing, say, an IT person, or without someone needing to have to do a lot of jugglery behind the scenes, is important. And typically that becomes difficult when you're using systems that are not meant for biobanking. The other challenge is with every study, every institute, every group, every study might have different data collection needs. For example, if you're collecting specimens for a COVID study versus a cancer study versus a diabetes study, etc., what data you want to collect, either clinical data or pathology data, test results, etc., would be different based on each one of these things. Again, ability to modify the system or configure the system per study based on these kinds of requirements, and add to it ability to report. For example, if you created a couple of new fields to collect clinical data, now would they be available in your reporting module automatically to do the queries? Those are the kinds of challenges that our typical customers face. Now, having to do all this without without much efforts, that is, without either paying the vendor like us to do these kinds of configurations, or having to have internal resources who are either IT skills or programming, etc., is important. So the biobank staff should be able to do most of these configurations themselves. This is especially like the cases like Indiana University, where there are large amount of users, large amount of specimens, etc. Ability to, or even in smaller biobanks, you might start with one biobank, but tomorrow you should be able to add multiple biobanks. Some other group says that, okay, we are also interested in this software. It should not They should not need to again procure a new license and have to do new installation, etc. They should be able to use OpenSpecimen within, like, multiple groups should be able to use the same instance of OpenSpecimen, where each group can see only their data but not others' data. So more number of people using in your institute, the better it is, because then the cost kind of gets amortized across multiple groups. And also, for your group, it is not like you are the only one managing the system. Integrations is critical. Ability to many times when a project is collecting specimens, they are collecting clinical data in REDCap. So how do you now bring in the REDCap data into the biobank system, so that when you are searching for specimens, you should be able to include include the filters or the conditions across both data sets, or Epic or hardwares like rack scanners, freezers, things like that. So those are the kinds of things you will find it very hard to do when you're using systems that are not built for biobanking. Now let's look at how OpenSpecimen solves these kinds of problems. First, about us, we have about 15, 16 years of experience working solely with with biobanks across the globe, and that is our experience, expertise, everything lies around this domain. We today work with about 100 plus research centers across 20 plus countries. And again, solely with in this field itself, it's not like generic lab or generic limb system that can be used across, like a water testing lab or a cannabis testing lab, etc. Most of our customers are in the US. We also have customers in Australia, Europe, a bit in Asia. Many of these customers that you see, one is well-known names. The second is also that they have been working with us for the last 10 years, 12 years, 15 years, etc. So, we are happy to give you references if you are, wanting to talk to someone who is already using OpenSpecimen. Some of these are our Australian clients, European clients. Our customers range from people using it across the university or across the enterprise. For example, Washington University in St. Louis have multiple biobanks within WashU using OpenSpecimen, where each, like I was saying earlier, each group can access only their studies, only their specimens, so kind of get their own compartment. But on the other side, we also have customers who are like single studies or single research groups, single PIs using OpenSpecimen. So we have we have customers across all ranges. We as a company are solely focused on OpenSpecimen, so that kind of enables us to improve the product rapidly. Listen to customer feedback, keep making improvements, and also provide customer support. We make new releases every 3 to 4 months with new features, bug fixes, improvements, etc. Talking about a typical workflow, this is what we call as specimen collection to utilization, tracking specimens from collection to utilization. That is, we start with steps like steps 1, 2, etc. could be done in other systems too. For example, you could be using REDCap to do consenting demographics. So whereas while OpenSpecimen supports this, but if you're doing it outside OpenSpecimen, you can just integrate it with those systems to pull data into OpenSpecimen. But if you're not using any of those systems, then you could do all these things in OpenSpecimen. So we start with consenting patients, registering patients, consenting patients, collecting. If, for example, if you want to collect a health survey questionnaire, you can do that in OpenSpecimen. So things like that, medical history of the patient. So depending on what is your study requirements, you can configure all that in OpenSpecimen. And now coming to specimens, you start with collecting the primary specimens, which is the things like whole blood or tissue, which is what you collect from the patient. And then at the biobank, you start, those specimens are processed into what we call as derivatives and then aliquots. That is, whole blood is processed into plasma, and then plasma is processed into 10 1 ml tubes and then stored in the biobank. So this whole processing from parent, child, grandchild kind of linkage between the specimens can all be tracked in OpenSpecimen. And also collecting additional data. So if you're running tests on those specimens, for example, a nano drop test or centrifugation, etc., you can track all those things. How many times did you freeze thaw? All those things can be tracked in OpenSpecimen. Finally, why you're doing all these things is to utilize the specimens. That is, when researchers come in and ask for specimens, you should be able to give it back to them. So even that module, where instead of researchers just emailing you guys, you can publish the specimen data in OpenSpecimen. They can come into the what we call as a catalog, submit requests. You can review those requests, process, approve, reject, and if it is approved, distribute the specimen. So as I said, right from collection until it is utilized, every step of the specimen can be tracked. And we support all kinds of collections. That is prospective collection, which is we are collecting specimens for future use. not necessarily knowing who's going to use it or when it is going to be used. Typically, these are disease-based biobanks, where it's a cancer biobank or a COVID biobank, etc. Or specimens that are collected for specific studies, where there is a study calendar, day 0, day 30, etc. And you know exactly what is going to be collected at each one of these events or time points. And then and what are you going to do with those specimens once you collect? Uh, so you can actually design the study calendar in OpenSpecimen. We also support multi-site studies. That is, many of our customers run studies across multiple sites in the US or even international, and then all the specimens come to a central location, and then they are stored locally or at the sites. That whole process of managing a multi-site study can be managed within OpenSpecimen. We also support non-human collections. We have got customers who are more veterinary, biobanks, or within existing customers, there could be one or two studies that are non-human. And also this applies for cell lines, microbiomes, etc. So we got people who do all kinds of collections using OpenSpecimen. So this is what we call as highly configure. That is, within an application, there could be different groups or different studies, each doing their own thing, and a combination of these kinds of things. Somebody running longitudinal studies, somebody running more disease-based biobanks, somebody running non-human collections, all within one instance. And all these configurations can be done by yourself, obviously with some amount of training, but fairly easily doable through the user interface. High level about the features. So this is a bit crowded slide, but because I'll also be showing these things in the live demo. Already talked about highly configurable forms and fields per study, like I was talking about questionnaires or surveys, etc., that you can do. Reporting granular user roles. That is, within a biobank, there could be people who are administrators, who are technicians, or supervisors, etc. So you can configure who can have what kind of access. Request distribution, I talked about. Configurable workflows like I was talking earlier about serum processing, plasma processing. These kinds of workflows can be configured. CSV imports is where you are you can import CSV files into OpenSpecimen. For example, you have legacy data, or you are getting data from some instruments, or you want to do things in bulk. You can pretty much every object in OpenSpecimen supports a CSV import. The last two are more technical in nature. The audit trail, etc., comes for compliance. So if you're a CAP certified lab or a ISO certified lab, etc., and you want to do and even basic security. For example, you want to go and see who modified XYZ in a specimen, when was it modified, etc. You should be able to pinpoint those kinds of things in the system. So, and that is what the audit trail allows you to do. Same thing, REST APIs again are needed for integrations, like when we integrate with RedCap or Epic, what we use is our REST APIs. We already support integrations with RedCap, OpenClinica, Epic, Copath, etc. We also have done a lot of integrations for in-house applications that people would have, and also with instruments. For example, automated freezers like Hamilton Bias, Azenta, Strata. And one thing missing here is the rack scanners, which is getting very popular nowadays with people, where, especially with high throughput labs, where you just scan the whole box at a time rather than having to scan individual specimens, one specimen at a time. So we do all those kinds of integrations. We keep creating new integrations based on requirements of people. So that's about as far as the background of OpenSpecimen is concerned. I will be now doing a demo of the system. OpenSpecimen is a browser-based application, like you would be using your email or this. Google Mail or Yahoo, etc. So you just have a browser, username, password. So it can be installed either within your institute or on our cloud. But you as an end user would have to just access the URL, which is which is provided by your administrator. The user accounts can also be integrated with your institute's login, so that you don't have to remember multiple username passwords. So let me go through one thing at a time. So I'll be doing this a bit quickly for the sake of time management. Like as I said, if you want a detailed demo, please let us know, and we'll be happy to do that. So we'll start with more high-level administrative stuff. So there is a module called roles, where you can configure different. The system comes with default roles, but you can also configure your own roles, which is basically to say who has what kind of access if they get this role. So if you're a clinician, you can read collection protocols, collect consent data, those kinds of things. And when you're creating users, what you do is you assign the role to the user, but you also assign um, yeah. So this is seems like a super administrator. Yeah. So you create a user with all the standard information like types and name, etc. But then there is a roles tab where you can say that this user has this specific role on this study or this site. So if you can give them access to all the studies in a site or a specific site. So now with this, you can granularly control who has what kind of access. So the same user can have different roles in different studies and things like that. So you can control who first of all which site they have access to. This is how you control the multiple biobanks or multiple groups using the same instance of OpenSpecimen. So that way they don't see data of some other site, etc. Moving on to a collection protocol. So collection protocol stands for a study or a project or whatever you want to call it. So we start with some basic details of the study. That is, what is the title of the study, who is the PI, and all those kinds of things. If it is a multi-site study, you can also enter the sites that are involved in the study, so that you can now grant access to the study based on the site. If you are going to collect consents within OpenSpecimen, you can also record the consent information. What we allow you to do is, typically there are two types of consents that are collected, right? One is broad-based consent, that is, the whole questionnaire is yes or no, whether you allow the biobank to process the specimens or do whatever they want to do with the specimens. The other kind of consent is where there are more consent questions, like specific questions being asked. Are you okay with DNA being processed? Are you okay with specimens being given out for commercial research? All those kinds of things, right? So now we allow you to collect consent at these individual questions level. So that way you'll be able to even create reports or look for specimens based on the answers to this consent. So that is the advantage of using recording consent information in OpenSpecimen. The other option is obviously to just upload the PDF file, and you're not really interested in individual things inside the PDF. You can also do that. So now coming to the study configuration. So what we allow you to do is configure time points, where each time point can have what you're going to collect at that time point. For example, in this time point baseline, you're collecting whole blood in red top, whole blood, serum vecutainer, urine, additional whole bloods, etc. And then also you are processing those specimens into different types. So this whole blood into processed into plasma and buffy coat, and then plasma is processed into aliquots and stored. So again, what we are showing here is the template being created. The actual specimens will be collected later. Here, this is just the study design being done. So some other, this whole blood is processed into serum. So similarly, for each time point, you can configure different kinds of specimens that are collected. So based on the SOP, etc., you can define what is going to be done with those specimens once it is collected. So this is basically the study design. And in case of, if it is a non-longitudinal, that is, there is no time points, you can just configure one time point and say that, okay, if you know what kind of specimens you are going to collect from the patients, you can just define that or just leave everything blank. The advantage of defining these things upfront is that the number of steps when you're collecting data becomes minimal, because all you're saying is whether you collected or not collected, or if there is some deviation. For example, instead of 10 ml, you collected only 5 ml. Instead of creating 10 aliquots, you created only 5 aliquots, right? So, but if you don't define anything, then you have to do the data entry from scratch. That is, you need to say, okay, this is a whole blood, this is of this type, every field has to be filled. But the more you pre-configure, those things will come automatically pre-populated. There are a lot of settings that you can do. For example, label printing. You can print labels from OpenSpecimen. You can pre-print. You can do kits. You can do dashboards. A lot of things I'm going to skip in this today's call. The next is configuring freezers, because once you collect those specimens, you're going to store them, right? So when I'm going to show you my demo freezer. So you can configure the freezer based on whatever you do, whatever is your freezer locally. So you could have freezer, rack, shelf, box. You could have directly, I think here we have just racks and then boxes. What is the there is no restriction on how these freezers can be configured. It is whatever you have in your lab. Now you can see the freezer in multiple ways. For example, this is a map view, where you can go to any level and see the map. For example, this is the rack. These are all the box that are stored. This is the box where actual specimens are stored. You can go up and down and view the specimens in a map view, or you can view the specimens in a list view. That is, these are all the actual specimens in that same box, just that it is shown in a list view, where you can see the specimens, etc. Sorry, I clicked on something. So that's about some of the configurations. I'll also talk about a few later. So now you've done all the configurations. You created the study, you created the containers, etc. Now you're ready to collect specimens. So the previous actions all would be done by an administrator, whereas now when you're actually registering the patients, etc., you can think of yourself as a technician or a supervisor, whoever has access to do these kinds of things in the lab. So what is the first step, right? So the first step is to register a patient. So let's look at a patient. So from here onwards, everything that you see can also be configured. For example, I was in this patient's list view. So the subject ID, so there are columns here like subject ID, name, patient number, etc., or these filters. All these things can be configured at a study level. So each study can have different views, different columns, different sets of fields here, all done through the user interface, by the administrator.
I put it in.
So for a patient, you can collect something like first name, last name, date of birth, a unique patient number if there is something like an epic number, or things like that, MRN, etc., consent file. The email address is all needed if you are going to send surveys to the patient. So again, what as I said, everything is configurable. So if you're not collecting email address, you can just hide this field. In some cases, people don't even collect any PHI in OpenSpecimen. So you can hide the first name, last name. You don't need to have all these fields displayed, and instead you can show only those fields which are needed for the users. Um or if there are additional fields, for example, if there is a question on the if which state do you live in, or address of the patient, or are you married, etc. So If there are one or two questions like that that you want to add on the patient form, you can also just add that. But if you're collecting, as I said, questionnaires, longer forms, then you can create a separate form. For example, this is a family history form, which is a short form. So, but these kinds of forms can be associated per study. So each study can have different forms, linked to based on whatever data you want to collect for that study. So this is typically, other option is to collect these kinds of data in REDCap. But then if you're not using REDCap or you want to integrate REDCap with OpenSpecimen, those things are also possible. Or if you're not using REDCap, you can directly create these forms in OpenSpecimen. So for example, this is a lifestyle questionnaire that you can, all these kinds of things. So anything that you want to collect for the patient, you can collect it here. These are the consents that were configured in the study. So based on that, the consents appear. Now, if you're collecting the consents, you can, say things like yes, withdrawn, or declined, etc. Consent date, witness, etc. can be done. So we also have a separate e-consenting module where you can send emails to the patient to do consenting from home, where they can sign from home. They can, you can have multiple languages. For example, Chinese, Spanish, or any other language that is necessary. You can do those kinds of things also, but that is a separate module. This is what comes default with OpenSpecimen. But if you're interested in more advanced consenting, we have got other options. So now going back, so at the top we saw the basic details of the patient. We also have audit trail, like I was saying, for every object. So you can see who created it, when was it last updated, what are the, how many times was it edited in the past, etc. Uh, Bottom, you see how many times has the patient already come. So what we call as visits. So how many visits have occurred and how many visits are pending. So the pending is coming from the collection protocol design. So we already said that this patient is expected to come 5 times, 6 times, and these are the time points. Now, based on that, it is showing that these are the time points. Now, the occurred visit is where the patient has already come and given the specimen. So let us have a look at that. Again, at the visit level, we track things like, which site did the visit occur, what was the clinical diagnosis, date, etc. And in this case, there is only one specimen that is collected, one specimen, one aliquot, but this shows the details. Maybe I'll go to a different patient where there is some more. Okay, this seems interesting. Okay, so here if you see, there are multiple specimens being collected. Each specimen, how the aliquots are created. The aliquots are stored in the contain in the freezer, etc. So all details are displayed here. That is because the specimens are already created. Now, if I go into an individual specimen, it will show me all the details of that specimen. What is the identifier? What is the label? If there is a barcode, there is no barcode in this case. What is the lineage? And one thing that I missed, so let's go back here. So you see, yeah, sorry. So you see that it maintains the whole specimen, child specimen, grandchild specimen, this whole hierarchy of this. So you can at any point go and look at from this specimen what child specimens were created, what grandchild specimens were created, etc. And you see all these are auto label formats that are defined for that study. So the system automatically labels it. You can also print those labels. So imagine you're collecting the specimens, you just collect the specimens, the labels are automatically printed. You can also configure that only aliquot should be printed because maybe you collect the primary specimens first and then process the aliquots. So based on whatever is your requirement, you can configure what kind of uh, and including what should be printed on the label, because different studies want different things printed on the label. So you can define all those kinds of things in the study configuration. So going back into the specimen, it shows all these basic details. It shows where the specimen is stored. This is in this box, in this location, etc. And each one of this is hyperlinked. You can actually go into that from here itself. So let me now collect a new specimen, new event. For example, if I go in, these are all the occurred ones. I'll have to go into. Okay, so now I'll collect the surgery time point. So when I collect the surgery time point, it asks me the details of the visit. When did the visit happen? Where did it happen, etc. I'll just leave the default. And it is this is what I was saying earlier, that if you're pre-configured, then the system starts showing you the details from the study. If you're not pre-configured, then you have to manually enter each one of these things, per specimen, which can be very time consuming. So okay, there's some configuration issue here. So let me collect some other. So this is a different visit. Hopefully this will go through. Okay, some issue. Anyway, so once you collect the specimens, it will start showing up, in the previous screen, like the what I showed for this patient here. It will start showing up here with all the details. I'll show that separately later. So that is the patient specimen details. So at the specimen level, if you see, not only does it show all the details of the specimen, it also shows all the events that has happened on the specimen, like when was it collected, when was it received in the lab, when was it processed into aliquots, etc. So if you click on this, it will show you like who was the user at what time point, if there was some comments. So this is more of, one is more of an audit of that specimen, like what has happened on that specimen. uh, but it can also be for, say, this is pending. Let me go So it can also be for other kinds of things. For example, if you ran a nano drop test, you can have an event for nano drop. If you ran a if you froze a specimen, you can have a frozen event. If you spin a specimen, you can have a spun event. So depending on each one of these things that you're doing on the specimen, it keeps on recording these details. And finally, once it is distributed, it will have a distributed event. So this kind of, you can, but just by looking at the events, you can see that all the things that has happened to that specimen throughout the life cycle of that specimen. Okay, so let us see if this has anything interesting. Okay, so that is about the patient, specimen, etc. Uh, as I said, along with the visit or the specimen, you can also collect pathology data. For example, if you want to collect prostate pathology, so these are all custom forms. These don't come with open specimen, so you have to create these forms in the system. There is a module called Forms where you can create. So if you're familiar with Google Forms or even RedCap Forms, it is similar to that, where you can go and say what kind of fields I want. I want a drop down, or I want a date, or I want a checkbox, radio button, etc. So you can create these kinds of forms. This is an example of a quite elaborate form that you can create. So this is at a visit level. Similarly, at the specimen level, also you can collect additional data. So this forms module is available at almost every level. For example, this is a DNA extraction form. So you can configure based on whatever you are doing. You can configure different kinds of data to be collected. And this is one of the power of OpenSpecimen, where not only can you create these forms, you can create it at different levels, like patient, visit, specimen. You can create it at specific study level. You can say that, like, a cancer study would have different form, data collection needs, versus a COVID form would have different data collection needs, etc. So you can create all these things using, normal biobank administrators can do it using the user interface with zero IT skills. Okay, so that's about the patient. So the other thing that I wanted to show about was this module called as workflows. If you're doing very specific processing, for example, this is a serum processing workflow. So you can create, this needs a bit of IT skills to create the workflows, or we can do it for you. But the advantage of this is that you can create very specific workflows based on your lab's needs. So for example, this is a plasma processing workflow. So you see here the steps. You see that the steps here can be: first you receive the specimen, you spin the tubes, you create derivatives, aliquots, and store the specimens. So basically what we are trying to do is try to mimic what happens in the lab when you collect the specimen. So you collect the specimen and then do what? So in this case, you receive the specimen. So once you receive the specimen, you spin the tube. So when you spin the tube, you collect these kinds of data. What is the G force? How long was it spun? What temperature, etc. And then what do you? So this is more of a wizard-like thing. You keep on doing next, next, next until, and you can decide what data to collect in each step until you create the aliquots and then store the aliquots in the freezer. So these kinds of custom, for example, this is a DNA processing workflow. So here you see, you start with the specimens are already created. You are now taking the specimen, and you go to the go to the next step. You go to what is this, DNA extraction, DNA quantification, then you do the aliquots and store the specimen. So depending on what you're doing with those specimens, you can, the advantage of doing this kind of workflow is that multiple steps are combined into one workflow. So now, instead of, and you can also do this for like 10 specimens at a time, 20 specimens at a time, so in bulk. So this brings down the data entry, the amount of time you'd spend on data entry drastically. So this is one of the new modules that we have just released in the last couple of years, and now is becoming more and more popular with our existing customers, because it brings down, otherwise you would have to, so DNA extraction is a different form, quantification is a different form, you'll have to do all these things in multiple steps, whereas here everything is pulled together into a wizard like configuration, where all you do is do next, 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 and you are done. So it also brings down the the possibility of errors, or the amount of training that is needed for users to use the system, because once the workflow is built, all your end users have to do is go into the workflow and follow the SOP without having to bother about rest of OpenSpecimen. So this is, yeah, so this is another workflow, the serum processing workflow. Start with clotting, centrifuge. Again, these are all developed based on specific customer needs. So you don't look at this and say, okay, we don't process serum like this, because this was one of the customers who wanted it this way. Your serum processing can be completely different. All we are trying to say here is that these workflows are an example of how very specific custom workflows can be developed based on your specific requirements. Okay, so that is about the uh, workflows. So now you collected the specimens, you stored the specimens. What do you do next? Is the is to do distribution of the specimen. So, for example, um, you, you, you have researchers who contact you, say that okay, we are doing these kinds of studies. They have IRB approval, and you agree to distribute specimens to them. So similar to building a collection protocol, you can build a distribution protocol, because for the same researcher, for the same project, you might be sending out specimens multiple times in a year, or multiple times, right? So suppose they want 1,000 specimens, you might be giving 100 specimen at a time, as and when you have those kinds of specimens. So you can build a distribution protocol, and also define what kind of specimens are needed for that study, what are the consent requirement of that study. So for example, if it is an external study, and if you are collecting consents for, do you consent for specimens being given out to outside this institute? So and you want to make sure that only those patients who have consented, you are giving out those specimens. So you can also build those kinds of validations in the system. You can reserve specimens for a protocol, so that those specimens are not by mistake given out to other other distribution protocols or other projects. So there are two things. There are protocol distribution protocols and orders. So order is basically how many times you have given the specimen. So for this particular distribution protocol, we have given the specimen multiple times. So this shows that these three specimens were given on this date by this person. This is the requester, this is the distributor, things like that. So and also you can create an invoice for distribution. So in this particular study, it is not done, but you can also track the how much is the cost per services, etc., so that you can submit this data to your finance team for invoicing. So lastly, I'll come to the reporting module. So as I was saying earlier, so reporting module is one of the most powerful aspects of OpenSpecimen, where you can any end user, any biobank user without any IT skills can do their own reporting. It is as simple as going into the reporting page, selecting the study, or if you and saying gender. So okay, so female add. Now let's see how many specimens are there. There are 97 female participants, about 4,000 specimens, but I am looking for, say, anatomic site equals, say, breast. Let's see if we have data. Oh, good. Okay. So there are 375. So now I can go on adding such, filters. So suppose I say I'm looking for DNA, because with each filter, the number of rows are going to keep decreasing. So, okay, there are only 9. So what I'll do in this particular case is, instead of adding a filter, I'll just say all and click this checkbox called parameterized, which I'll show you later what happens because of this. So specimen type. Let me also add a couple of more things. Gender. Yeah, so instead of this, let me see. Yeah, so let me add lineage and also parameterize it. Okay, so this is good enough for now. So I'm looking for female specimens with breast. So now okay. I need to now select the what data I want to see for this. So I want to see the subject ID, the site, registration date of the patient, and then the label, the type, anatomic site I already selected, available quantity, and where is it stored. Let's see, storage details. Okay, where are the? Oh, it's in container, I think. Okay, container details. So container, I'll just say column and the container name, and done. Okay. So you see that the fields that I selected as parameterized are shown on the left-hand side. Um, and the fields that are selected in the columns are shown on the right hand side as a filter. So it shows all the, so the PPID stands for participant protocol ID, kind of a subject ID or a de-identified ID for that patient, which is auto-generated by the system. So you see, so for the specimens that are stored, you see that it has the container name, which position, and also you can see the complete details um, of the hierarchy of the specimen, for example. So I'll show that later. So on the left hand side, what you see here is a live filter. Since I didn't put a condition on the type, I can now do the filtering of specimens using this live filter. For example, I can say, okay, show me only DNA. So it will filter the results only for DNA specimens. You see here only DNA. I can also say, okay, I want to see only the aliquots. So the more filters that I add, it will go on showing me, the specimens based on the. So what this allows you to do is, you can create the query, save it for future use, but then you can just use the live filters here to instead of having to edit the queries, you can just use the live filters to shortlist the specimens. These specimens, you can select these specimens, add it to a cart. Cart is like a wish list or a pick list kind of thing. You can have multiple carts. From there, oops, you can have multiple carts. From there, you can, since I not saved that query, so let me open an existing query. So you can save these queries so that you don't have to keep recreating these queries, and also you can share these queries with others in the lab. So, for example, there could be one or two people who are experts in creating the queries. You can just create the queries and share it with other users so that they can just run the query rather than having to sit and manually create those queries. You can also create the queries where instead of seeing like one specimen per row, you want to see counts of specimen. For example, you want to submit a summary, a monthly collection summary to the PI or to your management team as to how many specimens were collected for each study in this month. You can create those kinds of queries. Typically these kinds of things are done in Excel sheets, and you do pivot table formulas and all those things. You can do that within OpenSpecimen. Let me see if there is one more good query. Yeah, you see here, this query is number of specimens by specimen type for each protocol. It is showing how many specimens are there for each one of the specimen types. So these kinds of tables you can create and automate these queries being run. So the query module has a lot of features. For example, you can create a monthly report and say that this report should be run every month on its own on the first of the month and sent to XYZ people, so that you don't have to remember to come on like every first and run that manually, send it manually, etc. So that's the this one. So the last thing that I want to show is what is known as catalog. So for example, if I'm logged out of the system, you see this is a dashboard that you can create. This is now more for how do you make your biobank popular within your institute or even outside your institute. You can create a dashboard for people to come and see what kind of data you have. You can hyperlink this dashboard to your website. Suppose your biobank has a web page or a website, you can hyperlink it there, so people can come and see what kind of, this is configurable, so you can change what you see here, what kind of graphs, what kind of numbers are shown here, can all be done by you. You can decide, you can add more graphs, you can remove these graphs, etc. Right now, just for demo purpose, we have specimens by type, specimens by pathology status, specimens by anatomic site, clinical diagnosis, gender, etc. And you can also build a catalog. So this catalog is meant for like a e-commerce site for your Amazon for your biobank, right? So people can come and say, okay, I'm looking for, say, male between, the age at collection should be between, say, 20 to 50, and anatomic site is, say, lung. So things like this, you can, so again, typically what happens is that people approach you for, do you have these kinds of specimens? So now they should be able to come here, look at the details of the specimen and say, okay, this looks good, and add it to a cart. And once they are in the cart, they'll be able to submit a request where they can fill in a request form, which is based on whatever, details that you typically ask the requesters to. For example, you can ask them to upload a file like an MTA, material transfer agreement, to IRB ID, etc. And this will send a notification to the administrator that XYZ person is looking for these kinds of specimens. So now you can either approve, reject, ask them more questions. And if it is approved, if you remember, I showed you the distribution process, distribution protocol, orders, etc. Then you can go ahead and process the specimen to distribute the specimens to the researchers. So I'll stop there. So that is pretty much a high-level overview of the system. If anyone has any questions, feel free to ask us here, ask us in the chat, unmute yourself and ask, or email us the questions. We have last 1 minute left. That sounds good. So we'll share the recording with you guys. If you are interested, let us know. We are happy to set up a separate one-on-one call where we typically customize the demo based on your requirements, ask you what you're looking for and what kind of data you're collecting, etc. So that you can get a more customized, more personalized demo than a more generic demo like this. Thanks everyone for attending the call. We'll send you the recording shortly in the next couple of days.